Okay. On the board behind me, we have 3 different similarity postulates or similarity statements for triangles. In order to know that 2 triangles are similar, I can use any one of these 3 different criteria. The first one is called the angle-angle similarity postulate, or AA for short. If 2 triangles have 2 pairs of corresponding or matching angles that are congruent, then the 2 triangles are similar. If triangles have 2 pairs of corresponding angles that are equal, then the 2 triangles are similar. Knowing nothing about the side lengths, if I know that 2 angles are the same, 2 pairs of angles that are the same, then the 2 triangles are similar.
What does the P word say?
Postulate. Postulate is another word for statement in mathematics. An accepted statement of fact is called a postulate. P-O-S-T-U-L-A-T-E. Angle-angle, AA. 2 angles match, but the 2 triangles are similar. To the right, I have a pair of triangles. Triangle IGH and triangle JKL. In triangle IGH, angle G has a measure of 110 degrees, angle H has a measure of 40. In the second triangle, angle J has a measure of 40 degrees and angle L has a measure of 30. So I definitely see that it has 1 angle measure congruent. But I need 2. There's a congruent angle to match with that congruent angle. What would the other missing angle at I be? How can I figure that out? If I know 2 angles in a triangle, how can I find the third? Michael, you were saying this. Right. All 3 angles in a triangle have to have a sum of 180, so if you know 2 of the 3 angles, subtract those 2 away from 180. 110 and 40 make 150. How many more degrees to make 180? 30. So angle I has to be 30 degrees. That would now match with angle L over here. This angle is congruent to that angle. Or similarly, you could take triangle JKL and find its missing angle, which would have to also be 110, right? 30 and 40 make 70. I need 110 more degrees to make 180, which matches this angle G in the other triangle. Do these 2 triangles now have 2 angles that are the same? 2 pairs of angles that are the same? Yeah, at least 2, right? We found 2. The 30 that we found by matching I with L, the 40 that was given to us here in red. So those 2 triangles are congruent by AA, angle-angle postulate. I'm going to name those 2 similar triangles using this statement up above. If I go triangle GHI, what does G correspond with in this other triangle? G matches with K because they're both 110 degree angles. The order is important. If I go G to H to I have to match K with the G, J with the H, and L with the I. AA for angle A. The next statement, the next postulate is side angle side. I can prove that 2 triangles are similar by using side angle side, or SAS for short. SAS. If 2 sides of one triangle are proportional to 2 corresponding sides of another, and the angle between them, or the angle included by them, is congruent, then the 2 triangles are similar. Two sides of one triangle are proportional to 2 sides of another, and the angle between those 2 sides, or the angle included by those 2 sides, is the same. Then those 2 triangles are congruent. Let's look at an example of 2 triangles similar by what's called SAS. I have triangle BAE and triangle DEC. What would BE match with in the other triangle?
EC.
So 24 is to 36. What does that reduce down to? 24 over 36. 24 over 36. Say again, Steve. 24 is to 36 as 2 is to 3.
Yeah.
Let's see if the other pair of sides also is in that same proportion. DE is to AE, so 18 is to 27. I can divide 18 and 27 each by 9, so that's also 2/3. Looks like I have two pairs of sides that are proportional. Well, I need a missing angle, don't I? What angle's between those two sides? Here's BE and here's AE. What angle's between them?
Oh, we don't know.
This angle right here. That's the angle where those two sides meet. That's the angle between those two sides or included by those two sides. It's called SAS for a reason. Side, angle, side, with the angle between those two sides. Angle AEB is congruent to angle DEC by what are called vertical angles. That's a pair of vertical angles. Any angle pair that is directly across from each other, either left and the right, or the top and the bottom, makes what are called a pair of vertical angles. They're always congruent. So let's see if this checks off. Are two sides proportional?
Yes.
I have the angles between those two sides having the same measure. Is that angle pair congruent?
Yes.
So these two triangles are congruent by what is called SAS similarity. Triangle BEA is similar to triangle CED by SAS similarity. Is SAS the same as SSA?
No.
Why would that be different then? How?
Would be side angle.
Would the angle be between the two sides anymore?
No.
No. What if I had this angle matching with that angle? That SAS now. I moved where the congruent angle is labeled at. Is that angle between the two sides anymore?
No. It's going to be between the two sides.
That'd be the middle, right? This is angle side, or SSA or ASS. It's not the same as side angle side, SAS, for example. We've got AA, we've got SAS. What do you think SSS stands for?
Side.
Sure. So I'm pretty sure side would say that if all three sides are proportional in one triangle to another, then those two triangles are similar. If all three pairs of sides of two triangles are proportional, then the triangles are similar. The name kind of tells you what you're looking for. AA means look for two angles the same. SAS looks for two sides and the angle. SSS says look for all three sides between two triangles that are proportional. Then you will know that the two triangles are similar. Side, SSS. If all three pairs of corresponding sides between two triangles are proportional, then those triangles are similar. Now, one final pair of triangles to check using SSS. Let's see if I can make some ratios of sides and see if they're in proportion. The 10 at RS would match with the 14 from XY. So 10 is to 14. What would ST match with? The 15 pairs up with what?
X.
21. ST is the last two letters here. It would be in the same position as XZ using this statement over here. So 15 is to 21. That would leave me the 20 being proportional or corresponding with what side length?
Y.
What do all three of those ratios reduce down to?
1/2. No, just kidding.
10 is not 1/2 of 14. What can I reduce 10 14s down to? 5 over 7. How about 15 over 21? Divided both by 3, so that's still what makes 5 over 7. All three of those ratios are equivalent to 5 over 7. Are all three of these side pairs then proportional? Yeah. All three sides in the first triangle are proportional with all three side lengths in the second triangle. So obviously those two triangles have to be similar by what is called SSS, side, 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 similarity. Alright.
We're doing contact.
In a minute, I want to take a look at just these last two pairs of triangles up on the board here. A question like this is very similar to what's going to be on Con here for you. Are the pairs of triangles similar? If so, name them. Write the similarity statement that names them. Triangle DEF has a labeled angle of 60 and 75. Triangle ABC has other two labeled angles of 45 and 75. Let's see if we can use angle-angle similarity to say that these two pairs of triangles are similar or not. I need to find two pairs of angles between the triangles that are the same. Well, I obviously have E and C being the same, because they're both 75 degrees. Unfortunately, 60 doesn't match with 45. But what else could I use?
You could do 75 plus 60, and then that's 135.
So you're trying to find the other missing angle measure? The other missing angle measure? If 60 and 75 are two angles in a triangle, what's the third angle have to be?
45.
45. You're taking 180 minus 60 minus 75.
Yep.
So this is 45.
And that matches.
Well, now that matches with this.
And it just has to be 60.
Right. Or you could find this missing angle and match it with the 60 up above. Somebody last year said this. Look at these three numbers, 75, 45, and 60. What do they all have to add up to?
180.
So just take the three given numbers and see if they all make 180 to begin with. That would work too. Pretty much the same concept. These two triangles are similar by AA. So let's name them. Triangle, I'm going to go EFD. You can put it in any order. Once I write EFD, now I have to write the other one to match it. What would BCA? But E and B don't line up. E is the 75 degree angle. What's the 75 degree angle down below? CBA?
I did not know that. After the first study.
They're similar by what statement? What postulate again? AA.
Oh, Hopkins?
Lamore.
we're gonna teach about objects. I'm supposed to sign up for an email.
Okay, let's try another pair of angles. RST, XYW. Triangle RST has a right angle of 90 degrees and another measured angle of 32. The second triangle, WXY, has an angle 35 and 64. Are these two triangles similar?
No.
No.
They don't even have-
There's no way that I could match any two angles from one triangle with another pair of angles over here, right? These are not even close to being similar. Because they have different angle measures, they're different types of triangles in the first place. Similar figures are the same shape, different size. These are two different types of triangle shapes. Not similar at all. All right, so let's